Welcome back to another really exciting video with Mrs. Roberts. So this video is going to be the third video in my little mini series explaining how to solve trig equations. So in this video, we are going to go through some basic factoring. And before we get down to factoring with trig functions, I want us to factor just a normal function here. So let's say that I asked you to solve that equation right there. So when I ask you to solve this equation, what I'm asking you to do is find the values of x that make this true. So what values of x in 4x squared plus 2x makes the whole equation equal 0? Now, the way that I would go about solving this is I would try to factor the left-hand side. When you're factoring, you always want the function to equal 0. Otherwise, factoring doesn't work. So I would find the greatest common factor here. And my greatest common factor is 2x. So that 2x is going to go outside a set of parentheses. In math language, if you have a number here or anything here, and you open up a set of parentheses, it means this times this. So we're going to have 2x times, and we want to figure out what do we multiply 2x by to get an equivalent statement. So 2x times 2x gives me 4x squared, and 2x times 1 gives me 2x. So these are equivalent statements. And if you're worried about your factoring and you're worried that maybe you didn't factor it correctly, you can always plug it into Desmos and see if you are correct. So I'm going to go ahead and open up a Desmos here. And you're going to notice that in Desmos, I don't plug in the 0. I just plug in the function. And I plug in the function along the way to make sure I'm factoring it correctly. So 4x squared plus 2x. And I'm asking myself, is that the same thing as 2x plus 1? And it is the same thing because those graphs overlap. So I have factored correctly so far. Now, the beautiful thing about factoring is that when you factor, you can set each of your factors equal to 0 and get the overall answer. Now, it only works when it's equal to 0. It does not work when it's equal to 1 or 2 or 3 or 4. The way that factoring works is if I can figure out what makes this equal 0, it doesn't matter what this is. 0 times anything is going to equal 0. That doesn't work the same if this was a 1. You know what I mean? And then same with this. If I can make this equal 0, it doesn't matter what this is. 0 times anything is going to be 0. So you're going to take each of your factors, 2x is a factor, and you're going to set it equal to 0. Because if this equals 0, 0 times anything is 0. And you're going to work it all the way through. You're going to divide by 2, and you're going to get x equals 0. There is one of your zeros. Now you're going to take this factor and you're going to say 2x plus 1 equals 0, and you're going to work it all the way through, and you're going to get that your other 0 is x equals negative 1/2. Of course, these are the zeros of the function, so you could pull Desmos over and make sure that you did that correctly. We've got a 0 at negative 1/2 and at 0. But we've been doing that for a while. Why am I bringing that into this video right now? I'm bringing that into this video right now because that same idea, that same concept applies to trigonometric equations. So let's say we have an equation like cotangent of x times cosine squared of x equals 2 cotangent of x. Well, if I want to solve this, the first thing that I want to do is I want it to be set equal to 0. And you might be asking yourself, when do I know how to set it equal to 0 versus not? If you have more than one term with an x in it, then you should bring everything to the same side and try to set it equal to 0. If you only have one term with an x in it, then it's easy just to peel everything away from that x. But here, we have more than one term with an x in it, so I want this equation to be set equal to 0. So to do that, I'm going to subtract a 2 cotangent of x from both sides. Now, these are different terms, so they have to stay separate. So it's really going to look like this: 2 cotangent of x times cosine squared of x minus 2 cotangent of x equals 0. Okay, that looks pretty scary. You're looking at it, there's definitely more letters than there are numbers. What do we do here? Like, how do I go about this? Well, just like over here, we're looking for a greatest common factor. And I actually think that in trigonometric equations, the greatest common factor stands out a little bit more because here we had to deduct that I could divide both of them by 2. Here, it's just kind of slapping us in the face that both of them have a cotangent of x. So we're going to factor out our greatest common factor is going to be that cotangent of x. That's going to leave us with, so remember with this, 2 times what gave me that? Cotangent times what gives me this? Well, our leader has to be cosine squared because cotangent of x times cosine squared gives me this. Minus cotangent times what gives me 2 cotangent, and this has to be 2. Again, when you're reasoning through this, you want to multiply it back in and see, does that make sense? So cotangent times cosine squared is cotangent cosine squared. Cotangent times negative 2 is negative 2 cotangent of x. Now, just like before, we have different factors. If either of these factors equals 0, 0 times anything is 0. So we're going to do the same exact process here. We're going to take each of our factors and we're going to set them equal to 0. And we're going to work our way all the way through. So right now, I've got cotangent of x equals 0. I'm going to take the inverse cotangent of both sides. And so I want the inverse cotangent of 0. Now, to find what our x values are, we're going to take our handy dandy chart right here. We're going to go to the cotangent column, and we want to figure out what would the inputs be. And these are our inputs over here. So we're going to follow all the way through that cotangent column, and we're going to find when did cotangent equal 0. So cotangent, and I'm just mapping all the way down until I find a 0, and there it is at pi over 2. So I'm going to move my paper over, and I'm going to say x equals pi over 2. And then I'm going to continue and see if there's any other places that it equals it. So I'm moving down along the line, and there's another 0 right there at 3 pi over 2. And there aren't any other zeros in that column, but we have both of those answers right there. Now, we're not done yet because we've only set one factor equal to 0. We also need to set this factor equal to 0. So we're going to have cosine squared of x minus 2 equals 0. We're going to add 2. We're going to square root. Remember, every time you take a square root, you get the plus and the minus. So we are going to inverse cosine both sides. So we get x equals the inverse cosine of plus and minus root 2. Okay, we're going to take our handy dandy chart and we're going to look down the cosine column. And again, we're looking for the input that causes a root 2. And what I notice is there's not a plus or a minus square root 2 anywhere. There's root 2 over 2, but there's not just square root of 2. If that's the case, then what you want to do is you want to take your calculator. I'm going to make sure this is in radian mode. And you are going to use the inverse trig function. Hold on, I'm trying to move this. Right here, you can click this screen. And then if you click functions, the inverse cosine is right here. Didn't mean to put that there. And then you can plug in whatever you want. And so we're looking for the inverse cosine of the square root of 2, and it's undefined. So that means that the inverse cosine of the square root of 2 does not give us any zeros. So just that factor doesn't give us any zeros, and that's okay. We'll try the negative. It's still undefined. My last step when I'm working through these problems is to double check in Desmos that I have found all of the answers. So I have found these right here as my solutions. This did not give me any more solutions, so I just want to make sure using Desmos that this is correct. So using Desmos, I'm going to plug in this equation, cotangent of x times cosine squared of x. I'm going to drop down and I'm going to put in 2 cotangent of x. And I want to make sure I'm only looking before 2 pi. That's that green line right there. It's hard to see. I want to make sure that the answers that I got where they cross are pi over 2 and 3 pi over 2. So there are answers right there. All right. So what we just did there was we factored out a greatest common factor. So anytime you see something where you can factor out a greatest common factor, that's the process that you want to go through.